Okay, we've looked at derivatives of polynomials and different things like that. We've learned maybe the quotient rule, the product rule, the power rule. We probably haven't talked about trig functions yet. So let's dive in and talk about them. These are derivative rules for trig functions. So notice the Leibniz notation d dx of sine x. So this right here is f of x, the sine x, and this right here is f prime of x, the derivative, which in this case, the derivative of sine is cosine. And then if you're taking the derivative of cosine, well, its derivative, f prime of x, is negative sine of x. So then here's another one, derivative of tangent is secant squared, derivative of secant is secant tangent, derivative of cotangent is negative cosecant squared, and derivative of cosecant is negative cosecant cotangent. So all of these rules just need to be memorized. Now, there's really no need to prove them to you, but if you wanted to prove them, you'd be looking at the limit of the difference quotient. So you might evaluate the limit as h approaches 0, for example, of, in this case, I'll just write this one out for short, sine of x plus h minus sine of x, all divided by h. And when everything is said and done, you apply trigonometric identities, and this is, some properties for like a sum, for example, you end up with at the very end just cosine. So it's a long way to get there, but it is definitely possible to do it. And the idea here is that you just kind of take these rules, accept them for what they are, and use them where you need them. If you need to prove them, you're going to need to brush up on your pre-calculus or trigonometric identity skills. Otherwise, just take them, use them, apply them. All right, so let's go ahead and take a look at an example here. All right, I have y equal 4 over x plus 3 secant x, and I want to take the derivative. So first thing I need to do is rewrite this by writing it, suppose 4x to the negative 1, apply the properties of algebra there, exponents, bring that up, plus 3 secant x. And I already know that I'm going to apply, in this case, the power rule. So that's going to go here for the first part, and then this one is just the derivative, and I'm just going to abbreviate the derivative of the secant. Okay, so I've already got that on my chart down there at the bottom. So derivative of secant, just recall, is just secant tangent. So we're going to use that. So to find y prime, in this case, we're going to bring the power down, negative 1 times 4, negative 4, x to the minus 2, because you subtract 1, okay, plus 3, constant multiplier there, and the derivative of secant is secant tangent, so secant x tan x. All right, and there's nothing to it. There is nothing to it. You could clean it up just a little bit by writing it as negative 4 over x squared plus 3 secant tangent. And that's probably about all you would do. Otherwise, those two are really the same answer. So let's go ahead and take a look at another example. Okay, this next problem, slightly more challenging, but only because look at what you've got here. If you look here and here, you have to use the product rule. All right, but that's not too big of a deal. All right, the other thing is here you're dealing with a square root. All right, and you're probably like, wait a minute, we haven't dealt with square roots yet, but it's not that big of a deal. You got to think algebra. Think algebra. So let's go ahead and rewrite this, and I'm going to use a different colored pen here to rewrite it. T to the 4th tangent of t minus t to the 1/2 power, because the square root is the 1/2 power. So I'm going to go ahead and look at that derivative first, but let me just label here that this is u and this is v, and we're going to apply the product rule. So if I look here, I've got a negative t to the 1/2. All right, so what I'm going to do is I'm going to bring the power down. I'm going to have negative 1/2 t, and I'm going to subtract 1. 1/2 minus 1 is a negative 1/2. Think about it. Think about that. Okay? And so that's the derivative there, and you can clean it up, okay, by saying, well, this is just means that it's a square root in the denominator. So it's negative 1 over 2, and then it's square root of t. So you can leave it like that. That's okay. All right? But that would end up being the derivative of just this portion here. So we'd follow our way down this way, and we're going to need that. All right? But for the rest of this, we're going to have to use the product rule for the front portion anyway. All right, so let's go ahead and write out our u and our v. So our u here is t to the 4th. Our v is tangent of t. And our u prime is 4t cubed. We apply the power rule. And our v prime is the derivative of tangent, which is secant squared of t. All right, let me clean that up. And just pointing that out right here, it's this rule right there. Okay, and so then we put it all together. We kind of do this crisscross thing here. All right, we have, let's see, t to the 4th, secant squared of t plus, and I'm going to put the u prime first just for the sake of the order. It looks a little bit nicer. 4t cubed tangent of t, and then I'm going to put plus, and then a negative 1 over 2 square root of t. And so this is my y prime. This is the derivative right here. All right, it looked kind of ugly at the very beginning, but it's actually not that bad. You just really have to apply the rules. All right, I think we can look at a couple more examples, and we're going to make these really simple because we're actually going to make use of the fundamental identities that I have right here. So let's take a look at another example. Okay, in this example, I see that I have cosecant of x plus the cotangent of x times the cosecant of x minus the cotangent of x. I recognize this as something that I call dots, a difference of two squares. It coincidentally, that's also my favorite candy. If I have a plus b times a minus b, I get a square minus b square. Okay? A square minus b square. So that's what's going on here. You have a difference of two squares. This is a, this is b, a plus b, and a minus b. So all we have to do is square the first, square the second, and subtract. So let's write this out. Y equals then the cosecant of x squared minus the cotangent of x squared. All right. Now we're going to use the fundamental identities that involve cosecant squared or cotangent squared, and I actually see it right here, this one right there. And with a little bit of manipulation of it, let's write that out underneath here. If I take 1 plus the cotangent squared of x and set it equal to the cosecant squared of x, that's the identity. If I move this to the other side, I have 1 equals cosecant, and let me get my pen back. Give me 1 second. There it is, cosecant squared x minus the cotangent squared of x, something like that. So that's just 1. So if I come back up here at the top, I know that this identity over here was just 1. Okay? It's just 1. So y equals 1. Whoa, my pen's acting up here. All right, y equals 1. And if I take the derivative of 1, well, the derivative of any constant is 0. So y prime equals 0. So that one is actually easily done. The derivative there of number 3 is just 0. All right, it's actually kind of cool. All right, let's take a look at one more example. Okay, here on this example number 4, we're also going to make use of the identities. So first thing I'm going to do is rewrite it. Okay, I'm going to rewrite it as 4 over sine x. So 1 over sine x is this one right over here. And let me highlight that. 1 over the sine of x is the cosecant of x. So I'm going to write it as 4 cosecant of x. Okay. And then 1 over the cotangent. Well, that one is straight off of one of these identities. It's actually the reciprocal of this one right here. So they actually swap places. So the tangent of x is 1 over the cotangent. All right. So this one should say plus the cotangent. All right. Now to take the derivative, it's actually really simple. And let me go ahead and bring those rules back into place for you. Give me 1 second. So here are the rules. The derivative of cosecant is, where is it? Right here. Negative cosecant cotangent. Okay. So I have a negative 4 cosecant cotangent. Plus, and then the derivative of the cotangent. And so then the derivative of the cotangent right here is going to be that negative cosecant squared. So let me just write that. Negative cosecant squared. So that right there is how we would take the derivative of that function. So really no quotient rule involved. Just use trig identities. All right. And it actually makes it really easy. So I hope this video was helpful. And as always, like and subscribe.